Okay, friends, so welcome to the video version of the practice exam. Apologies for the lighting and my voice, but it is relatively late at night, i.e. after the kids went to bed on Friday evening. So let's take a look at this practice exam. First question. So we've got a pretty standard bunch of resistors that are being powered by a battery. We're given all of the resistances of all the resistors up here and the voltage of the battery, and we're asked some questions that should be pretty familiar to us down here. So first, calculate the total current flowing in this circuit. Okay, so let's take a look at that. We know that the total current is equal to the total voltage over the total resistance. We already know the total voltage applied to the circuit, that's 9 volts, but we don't know what the total resistance is quite yet. And we've got 5 resistors here, so it'll take a little bit of simplification. And I'm going to start by simplifying R4 and R5. They are in series with each other because they must experience the same current, because the same current comes out of the battery, part splits off into R1, part splits off into R3, and then the last bit must go through both R5 and R4 to join up with the other currents and return to the battery. So R4 and R5 are in series, so we just add them, and they are both, according to the problem statement, 50 ohms. So we end up with 100 ohms. Okay, that's a omega for ohms, not an R, cursive R or something. Okay, so we've got 4 and 5 taken care of. 4 and 5 combined are in parallel, rather, with R3. You know that because you can go through just wire to the top of the R4, R5 combination up there, and you can go to the bottom of the R4, R5 combination there from the other side of R3. So we know that R3 and that combo is in parallel. And R3 is 80 ohms. So R3, 4, 5, all those together is going to be equal to 1 over 80 ohms, which is the resistance value of R3, and 1 over 100 ohms, which is the resistance value of R4 plus R5. We flip all that over, and when we do that, what do we get? Let's type it into the calculator over here to my right. We add that up, we flip it over, and we get 44.444444 repeating. Now we've got 2 more resistors to go, so R2, 3, 4, 5 is going to be just 44.4444444444444444 combined with R2, which is just 30 ohms. We know they're in series because whatever current goes through this whole combination up here must also go through R2 before it forms up with the current going through R1 and then returns to the battery. So when we do that, we get 74.4 repeating ohms. And then finally, our total is going to be R2, 3, 4, 5 in parallel with R1. So we get 1 over that 74.4 repeating ohms plus 1 over 30 ohms, that's R1. We flip all of that over, so we take it to the minus 1 exponent. And when we type that in, so we flip that over, we add it to 1 over 30, and then we flip that whole thing over to get 21.4 ohms of total resistance. Okay, hopefully I've done that correctly. And we take that value and we bring it back over here, and we've got 9 volts divided by 21.4 ohms, and that gives us about 4/10 of an amp. flowing through the circuit. Okay, so that's part A. I will say that this is probably on the more complex side than, if you can solve this, if you're feeling confident identifying what's in series and what's in parallel, and you worked right through this and this was no problem, then hey, you're probably okay for whatever you're going to run into in this kind of question for the final exam. Okay, if this is still a little bit of a mystery to you, well, it's worth going back and trying out a bunch of the other series parallel problems we might be dealing with or have dealt with in the course and thus might be dealing with on the final exam. All right, so let's go up to, or down to, part B. Determine which resistor dissipates the largest amount of power. Now we could do this the brute force way, right? We could go through and work through and find every single resistor's power dissipation, but that is a fool's errand if we're on a time limit, okay? Let's think about this a little bit. When we've got, say, R2345 in parallel with R1, R2345 is bigger, that 44.4 ohms is bigger than that 30 ohms of R1. So we know just from that the majority of the current is going to be going through R1, right? Rather than going and then splitting a bunch of times over here in the other resistors, okay? So that suggests that R1 is getting more current than the other resistor. And if you look at the voltage, well, R1 is in parallel with the battery. So it's going to receive all 9 volts. So not only does it have the most current going through it, but it's also definitely got the most voltage difference across it. And so that is going to be the one that dissipates the most power, that uses the most power. So P1 is V1 squared over R1. That's 9 volts squared over 30 ohms. Move that up a little bit. And so we've got 81 over 30, which is 2.7 watts. Okay? So, if you were to go through and find all of the other powers, you would find them to be less than this. If you were answering this on the exam, this probably would not be quite enough to satisfy me, because that shows me that you know how to calculate the power through R1, or rather being used by R1, but it doesn't tell me like why you believe that to be the largest amount of power. So say R1 in parallel with battery, and no other R is. Okay, that covers it, because that tells us that the voltage difference across R1 is bigger than any of those other batteries, and that certainly narrows it down. I mean, you could also, maybe just to say one more thing, is that, its current is going to be greater, but that would probably be enough. Okay, so C, if you wanted to double the voltage difference applied to this circuit and double how long the circuit will receive current, what combination of 9-volt batteries would accomplish this task? Draw your solution below. Okay, so we want to double the voltage difference. So we know that we must be putting 2 batteries in series, right? Because if we want to increase the voltage difference, we have to be putting batteries in series, because if you don't, then you don't add to the voltage. Just putting things in parallel doesn't change the voltage, it changes the capacity, right? So, now it also says double how long the circuit will receive current. Okay, well then in that case, now that we've got this sort of baseline 9 volts and 9 volts, so doubling it to 18 volts, well then we just stick another combo of that same voltage in parallel. Now we've got 2 branches. You recall that now whatever the total current flowing from this to whatever circuit we've got in this thing, well, that now is being half supplied by this combo of batteries and half supplied by this combo of batteries, and that'll add up to that total current okay? And the capacity is increased because now each one of these batteries is only responsible for supplying half of the total current, so its total amount of charge that it has will be depleted more slowly, at half the rate, okay? So twice as slowly. Okay, so that's the solution to that one, and that's the end to the first question. We'll move on to the other ones probably tomorrow morning sometime. Thanks for listening.